31 feet in 90 minutes. The 2025 Central Texas Flash Flood, explained through a hydrometeorology perspective. July 15th, 2025. It was a sunny summer afternoon in the Texas Hill Country. By the time night rolled around, the Guadalupe River would rise an unheard of 31 feet in just 90 minutes, taking away homes, campers, and more than 135 lives. I'm Seth, and I'm going to cover one of the deadliest flash floods in Texas history and what hydrometeorology can teach us about this event and what could possibly be done to stop the next one. Flash floods are the second most lethal hydrometeorological events in the United States, behind heat waves. This event dropped 10 to 17 inches of rain in under 6 hours on already saturated soils. That's a 500-year rainfall in some places. The human cost: 135 plus fatalities, $2 billion in damage, and an entire summer camp washed away. From a hydrometeorology perspective, variables lined up together to cause detrimental effects such as atmospheric moisture, stalled boundaries, and land surface feedbacks. These are areas that meteorologists study to save lives. A stationary front stood across central Texas and acted like a brick wall, allowing systems to cultivate over the area. With tropical moisture moving north from the Gulf, dew points in the upper 70s converged into the front, what resulted a classic training line of thunderstorms that sat over the same watershed for hours. Let's break it down with the data. First, radar. National Weather Service dual polarization radar showed reflectivity cores over 65 decibels and correlation coefficient drops, telltale signs of huge raindrops and hail melting into torrential rain. The storms trained repeatedly over the Guadalupe, producing rainfall rates that hit 5 to 7 inches per hour. Second, the land was primed. Antecedent soil moisture from weeks of rain was above the 90th percentile. You can see it here on the NASA satellite map. Almost no infiltration, of nearly 100% runoff. Third, the terrain foam. Steep limestone canyons of the hill country turned small creeks into raging walls of water. USGS gauges recorded the river jumping from 5 to 36 feet in under 2 hours. Look at this hydrograph. Finally, the forecast. The high-resolution ensemble forecast painted 60 to 80% probabilities of 6+ inches as early as the night before. Warnings were issued, but many people never got them in time. This event was not just a coincidence of circumstances. Warmer Gulf waters from climate change are loading the atmosphere with more moisture, which is what exactly supercharged this event. Hydrometeorology gives us the tools to fight back with better radar calibration, soil moisture satellites, probabilistic guidance, and real-time flash flood models. If we listen to the science, we can turn deadly surprises into survivable warnings. So next time you hear, turn around, don't drown. Remember the Guadalupe. One decision can save your life. And check your local flood risk. Thank you for watching. Let's keep each other safe out there.